So research into the brain has been helped immensely by what's known as functional imaging technologies, right? And I did suggest, for example, that some of these EEG ERP techniques can be construed as imaging technologies, although again or functional imaging technologies, although again the pictures that they generate are not very pretty. They're not very nice. They're not very detailed. They don't end up in on the front page of the New York Times or something, showing you a beautiful image of the brain. So EEG ERP I'm including here as functional imaging techniques because the electrical recordings that you do get are functional in nature. They tell you something functional about the brain. But these other techniques probably have better images. CAT is computerized axial tomography, which basically is the use of X-rays to multiple X-rays to extract information about structure. This is actually typically more of an imaging technique without necessarily a direct functional kind of assessment of if somebody's engaged in some task and you're going to see what areas are active. CAT is not your technique, but CAT, because you're different structures in the brain permit the passage of X-rays to different extents. You can get a great deal of data about, for example, the presence of a tumor in the brain in a particular location or some other kind of malformation of the brain. And that will tell you something functional about the brain. If somebody's having, for example, visual problems and you see a large mass that's sort of growing an occipital lobe, you have a sense, you have a good sense that that structure is related to function. And a computerized axial tomography or CAT scan can tell you that. All of these techniques, I want to talk about PET and MRI, fMRI in a minute in separate video segments. But all of these techniques have actually have improved our ability to sort of non-invasively observe anatomy in living patients and experimental subjects. So they've had a tremendous impact on our ability to see brain structure, right? It's a major boon to clinical research in the everyday work of doctors. You can localize lesions, right, or tumors, detect neurological damage and disease. And in addition, it's had a big impact on our understanding of the relationship of structure to function. So it has allowed neuroscientists to examine multiple areas of activation, and that's in quotes because we're going to talk about what that means in terms of PET and fMRI in particular. What activation are you actually observing? EEG, ERP, it's pretty clear. You're measuring the electrical activity of neurons. But PET, fMRI, it's going to be a little different in terms of what you're actually recording that gives you sort of functional information. But it's allowed neuroscientists, all of these techniques, to examine multiple areas of activation and correlate activity with specific sensations, reactions, and behaviors.